Good morning. Hope everybody is doing good. So we have almost 10 participants, I guess. Right. Okay. And I think we'll just wait for one more minute. Let me see if people joins and then we'll start. And I think we can start and share my screen. So I have to show you. I mean, we complete all the activities if you can remember. Okay, we have actually completed all the 11 activities, I suppose. No, only 10 activities are completed. 11th activity is oxidation reduction. We'll see what is going to happen there. So before we move on to this activity, we'll see what is oxidation reduction, what are the real life example, corrosion, all this stuff. We'll see it. Okay, fine. So maybe I think I'll go back, add a new page. Today is 4/07. Right. Okay. Fine. So we saw all different types of reactions. Like we said that we can have 4 basic types of reactions, namely combination, or it can have decomposition, or displacement, or double displacement. We saw all of these in depth. Right now, there is only one class of reaction which is left out, and that is what is my oxidation and reduction. Okay, fine. You must have been studying about this oxidation reduction from your previous classes. I think from your lower classes, even from 7th or 8th, right? You must have at least be hearing this term, right? Oxidation reduction, right? So I think some of you will know how am I going to define oxidation, or how am I going to define reduction, right? So there are various ways to define oxidation. For example, oxidation is a process where you add oxygen or you remove hydrogen. Right now, these two are the constant things they say, is it not? Say, for example, if I tell that I have H2 and it's reacting with O2 to form H2O, right? So what you're doing here, I have H2, to that you are adding O2, right? You are having H2, to that you are adding O2, right? So whenever you add O2 to something, right, that something is the one which is getting oxidized. Okay, that's something. Whenever you add oxygen to something, to whichever thing you are adding, right, now that particular thing is said to be oxidized, right? So you can see addition of oxygen, you are adding oxygen to hydrogen, so hydrogen is getting oxidized, right? Okay, fine. Next. Now these two are the only examples, right? So you have addition of oxygen and removal of hydrogen. But I can even speak in terms of electrons, people, right? So you must have known that in a chemical reaction, electron loss happens, electron gain happens, right? All this stuff also happens. So I can say that in case of oxidation, it is loss of electrons. Okay, so whenever something loses electron, for example, I'll tell you this, right? Sodium reacts with chlorine to form NaCl. Very simple reaction, right? Now you see sodium in its elemental state, that means its charge is 0 here, right? There's no charge on sodium, there is no charge on chlorine, 0 again, right? But if you go for NaCl, you know what I have in NaCl. I have Na plus ion and Cl minus ion. Correct. So for sodium to form Na plus, obviously I should have lost an electron out. Correct. For sodium to form sodium plus ion, right? That sodium should have lost electrons. So I will call sodium as sodium is getting oxidized. Why? Just now I told you that oxidation can also be defined in terms of loss of electron. Whenever something loses electron, that particular thing is said to be oxidized, right? So sodium here is forming Na plus, and how it will form Na plus? By losing an electron. So obviously sodium is the one which is getting oxidized because it has lost electron to form Na plus. Okay, now same way I'll be able to define reduction also exactly opposite of all these three, right? Either it is going to be addition of hydrogen, or it is going to be removal of oxygen, or it is going to be gain of electrons. Okay, right. Now, you see, I'll take these two examples itself for us to explain this. Now, I said you that to hydrogen, you add oxygen, right? So to hydrogen, you add oxygen. So hydrogen is getting oxidized, right? But if you see what is happening to O2, oxygen here, right? To O2, you are actually adding H2. To O2, you are actually adding H2. So I can say that this oxygen is getting reduced. Is it not? Because I told you addition of hydrogen to something is reduction, and whatever is getting, whichever is getting added up to hydrogen, that is the one which is getting reduced, right? So in this case, hydrogen accepts oxygen, so oxygen oxidized, oxygen accepts hydrogen, so oxygen is reduced. Right? Now, if I speak in terms of gain of electrons, right? Now, as I said last time, sodium has lost electron to Na plus, so it is oxidized, right? But if I take chlorine, we know chlorine has to form Cl minus. Is it not? In NaCl, sodium in chlorine exists as Cl minus ion, right? So for Cl2 to form chlorine, obviously you would have added electron to chlorine, right? So chlorine is the one which is getting reduced because you have gain of electron, basically addition of electron to chlorine. Okay, right? So sodium lost electron to form Na plus, oxidation. Chlorine gains electron to form Cl minus, so Cl2 is getting reduced, right? Okay, maybe I'll give you one more example, right? Say I have H2S plus chlorine gas, chlorine forms HCl plus S. Okay, sulfur H2. Okay, this is the reaction, right? Okay. Now, if you see which is getting oxidized, which is getting reduced. Okay. Now, in these kind of questions, you see there is no oxygen, there is no hydrogen is there, obviously, right? But there is no oxygen, or you're not adding exactly adding hydrogen or oxygen. But this reaction can also be termed in terms of oxidation and reduction. We'll try to understand how this happens. Okay. Now, all you have to look at, see, whenever you're talking about oxidation reduction, generally we don't speak about hydrogen and oxygen. Right, but you can ask me, sir, like in this question, like in this particular equation, we spoke about hydrogen and oxygen. Now, why we spoke about hydrogen and oxygen? Because these two are the only elements present, right? H2 and O2 are the only elements present in this reaction, right? But other than that, if at all you have any other reactant, any other product, in the sense that say, in this case, you see you have sulfur, chlorine, other than hydrogen, right? So whenever these kind of situation arises, right, remember that you do not have to worry about oxygen and hydrogen. Remember this. You do not have to worry about oxygen and hydrogen. Basically, in this case, I'm telling you, you do not have to worry about hydrogen, right? But if in these kind of reactions, that one, if you have only hydrogen and oxygen, then obviously there is no other choice than to speak in terms of hydrogen and oxygen. But if not, if a situation like this arises, there is no need to speak about hydrogen. You have to speak about the other two elements, that is sulfur and chlorine. Okay, fine. Now we have to just concentrate on these two, sulfur and chlorine. We'll see what is happening to them, which is getting oxidized, which is getting reduced. Okay, fine. Now if you look at this compound people, H2S, hydrogen sulfide, right? Now you see sulfur is along with hydrogen. Is it not? In the reactant side, sulfur is along with hydrogen. Okay, now you see where is sulfur in the product side? Sulfur is here in the product side, right? And what had happened to sulfur? Initially in the reactant side, sulfur was with hydrogen, right? But in the product side, sulfur has lost hydrogen. Hope you understand, right? Initially in the reactant side, sulfur was with hydrogen. In the product side, sulfur is not with hydrogen. It has lost hydrogen, right? So if it has lost hydrogen, what is it? Oxidation or reduction? If sulfur has lost hydrogen, if sulfur has lost hydrogen, it is oxidation or reduction? Oxidation. So in this case, I will tell that sulfur is getting oxidized, or sulfur is the one which is undergoing oxidation. Why? Because here I had hydrogen. In the product side, I don't have hydrogen. You can see here, removal of hydrogen or addition of oxygen. Either of that is oxidation. Correct? Okay, fine. So everybody understood that sulfur is the one which is undergoing oxidation, or sulfur is the one which is getting oxidized. Right? Okay, we'll speak about chlorine now. Right. Now, chlorine, you see, in the reactant side, chlorine was just there, or nothing, only chlorine is there in the reactant side. But when you go to product side, see, this is where chlorine is, but that chlorine is along with hydrogen. That means what? To chlorine, you have added hydrogen. Is it not? To chlorine, you have added hydrogen. So whenever you add hydrogen, obviously I know that that is the one which is undergoing a reduction. Right? So again, I repeat, chlorine in the reactant side doesn't have hydrogen, but in the product side, it has hydrogen. So it has added hydrogen to chlorine. That means chlorine is undergoing reduction, sulfur is undergoing oxidation. Okay, I hope I made sense. Okay, so like this.
So it is not necessary for oxygen and both, meaning like both hydrogen and oxygen to be there. A one is there also, is it okay?
Correct, exactly. Even though, see, in this particular reaction, you see sodium plus chlorine giving NaCl. I don't have any of them. No hydrogen, no oxygen. But still, I'm able to speak that something is getting oxidized, something is getting reduced. Right? So that previous old definitions only require hydrogen or oxygen in the example. Right? But in the modern definitions, in what we do in our day-to-day life today, right? We really don't need either of them. We don't need hydrogen. We don't need oxygen also. You can look at this reaction for that matter, right? Sodium is losing electron, so oxidation. Chlorine is accepting electron, so chlorine is undergoing reduction, right? But again, for your level, but they will not be, I don't think that they'll be asking you these kind of questions. In 90% of the questions you're going to get, either you're going to have hydrogen or oxygen present, so that you'll be able to understand which is undergoing reduction, which is undergoing oxidation. Okay, right, fine. Now, I want to get into the next concept. The next concept is oxidizing and reducing agent. Very important. Okay. Now, before we move on to this, concept, I want to stress one point, very important point to you. Right. Now, you have seen three reactions here, right? One is this, second one is this NaCl, third one is this reaction. Right. In all these reactions, what do you see in common? Can someone tell me? There is one thing you see common in all these reactions. What is the thing? It can be a wild guess. What is one common thing you are seeing in all the reactions? Simple answer, right? What do you see common in all three?
Sir, all are combination reactions.
All are, oh no. It's not, okay. All are not, what is it? You're telling that all of them are combination reactions? Yes, not necessarily. Okay, actually, yeah, these two are combination, but this is not combination, right? This is displacement. This particular reaction is displacement reaction. But again, that is not the answer. The common thing is you have both oxidation and reduction happening in all these reactions. So what I'm trying to say is there is no reaction where only oxidation happens, or there is no reaction where only reduction happens. If there is oxidation happening in a reaction, reduction will definitely happen. They will happen only simultaneously. They cannot act separately. Hope you understand the point, right? There is no one reaction where only oxidation happens. Impossible. There is no one reaction where only reduction happens. If oxidation happens or if reduction happens, the other thing is bound to happen. There is no other way. If something is getting oxidized, something has to get reduced. There's no other way. You can take any reaction for that matter, right? For example, right? For example, I can tell you this. You can say, there's common questions people will ask, sir, if I have this reaction, C plus O2 giving CO2. Okay, now this is an oxidation reaction only, correct? The answer is no. This is not an oxidation reaction, right? I will prove it to you how, right? Say two carbon, if it like see, please understand, whenever you are speaking about oxidation or reduction, you cannot speak with respect to the reaction as a whole, right? You cannot say that, okay, this is oxidation reaction or this is reduction reaction. You have to speak only with respect to a particular element or a particular compound, in the sense that either you can speak in terms of carbon getting oxidized or reduced, or you can speak about oxygen getting oxidized or reduced, right? Say even in the previous example you would have seen, we spoke about two things, one substance getting oxidized, another substance getting reduced. Here also one substance getting oxidized, another substance getting reduced. Here also one getting oxidized, another getting reduced, right? So what I'm trying to tell you is that you cannot speak about oxidation reduction with the reaction as a whole. No. In the reaction, you are going to take a particular element or a particular compound and see whether that particular element of or compound is getting oxidized or reduced. That is how we speak, not with respect to the whole reaction. Okay, fine. So let me prove you that this is a redox reaction. So basically, whenever oxidation and reduction happen simultaneously, those kind of reactions are what are called as redox reactions. Reduction, oxidation happening simultaneously. Okay, redox, reduction, oxidation. Anyways, so we'll try to prove that this is again a redox reaction in the sense that both oxidation as well as reduction is happening. Okay, fine. So carbon you see here, carbon in the reactant side doesn't have oxygen, but in the product side it has oxygen. So I can say that carbon is the one which is getting oxidized. No doubt about this, guys. This is very simple, right? Carbon doesn't have oxygen in the reactant side, but in the product side it has oxygen. So I would say that carbon is getting oxidized. Very simple, right? Fine. Now I told you that we have to have reduction also happening. For that, I have to look into oxygen. Okay. Now think about it and tell me, what is the charge of this oxygen? Like I have O2, right? O2, what is the charge here? Any idea? O2, what is the charge for oxygen? Any wild guesses? Come on, it's just a guess. You can tell any number for that matter, any reasonable number. Yes, any guesses? What is the charge for oxygen here? No numbers you want to tell? Sorry?
2 minus, sir.
Okay, that's what we think, right? Oxygen generally forms 2-. Okay, fine. It is correct, but not in this case. But please understand, people, whenever you have an element in its native state, we know what is a native state or free state, we call it, right? For that, the charge is always 0. Okay. Now, when what do you mean by native state? We know how it exists in the atmosphere, right? So whenever you have O2, Cl2, you can see from this reaction also. See, look at here. For Cl2, what we told as a charge, we told the charge of Cl2 as 0, because that is how it exists in nature, right? So whenever you see elements in their elemental state or their native state, their charge is 0. For example, O2, Cl2, H2, N2, all these will have a charge of 0. All the elements, hydrogen, nitrogen, chlorine, oxygen, all of them will have a charge of 0. Same way, not only these O2, Cl2, N2, all this stuff, even magnesium, sodium, what to say, whatever it is, right? All of them will have a charge of 0. In the sense that if I write a reaction like this, again, you can see in this reaction, sodium, I wrote, this is the elemental state. Again, you can see the charge is 0 here. Okay, so what you have to understand is whenever the elements are in their native state, right, their charge is 0. Okay, right, this you have to remember. Right, fine. Again, so you can understand that oxygen is in its elemental state, that is native state. So here the charge is 0. Okay, fine. Now, what about the oxygen here? Here also I have oxygen, right? Now this oxygen would have had a charge of what? What will be the charge of oxygen here? What do you think? There it was 0. Here it should be. Here it should be. Come on, I know oxygen from what ion?
2, sir.
Yes, -2. Right? This oxygen will have -2. Anyway, you don't have to worry about it. Right? These kind of questions are not going to be asked. I'm just trying to explain you that any reaction where oxidation happens, the reduction also will happen. That is the only thing I wanted to prove to you. Okay, so here we have already established that carbon is getting oxidized because to carbon I add oxygen, no doubt, right? Fine. So you see here, guys, oxygen, what is happening? The charge of oxygen was 0 here because it is in its native state. Right now, if you look at this side oxygen, just now we mentioned that it is going to have a charge of -2. Right. So from 0, if you want to go to -2, obviously I would have added 2 electrons to oxygen. Correct. From 0, if you want to go to -2 for oxygen, to oxygen, I would have added 2 electrons. Correct. Now we'll go back to the definition. Whenever you have gain of electron happening, right? That is what is reduction. So in this case, oxygen is the one which is undergoing reduction because it is accepting 2 electrons to form O2 minus. Okay, so even though this reaction looks like an oxidation reaction, right? It is not just oxidation, both oxidation as well as reduction happens. Carbon is getting oxidized because to carbon I add oxygen, and oxygen is undergoing reduction because it is accepting 2 electrons to form O2 minus. Okay, so like this, any reaction you take, you will have both oxidation as well as reduction happening. Okay, so this point I wanted to stress. I hope everything is clear. Right, now we'll speak about this one. What do you mean by oxidizing and reducing agent? Okay, fine. Now, generally people, say for example, I have an LIC agent. Right, I think you must have seen your father or mother speaking about this LIC policies, LIC agents and stuff. Right, so generally an agent, right, an agent is the one which helps you get something. Right, say for example, LIC agent helps you get an LIC policy. Right, say if I tell in biology, you would have seen this term called as pollinating agents. Yes, have you seen, guys, pollinating agents? Have you heard this term?
Yes, sir.
Yes, sir.
Right. Yes, you must have heard this term pollinating agents. So these insects, wind, air, all these are pollinating agents. Right. So what are they going to do? They are going to help in pollination. As simple as that. Right. So what you understand is an agent is something which helps in doing something or get you something. That kind of stuff these agents do. Right. So same way, oxidizing or reducing agent helps in oxidation or helps in reduction, depending on what type of agent it is. Okay, now it is not a big deal for us to find out which is the oxidizing and reducing agent in the reaction. It's very simple, right? Say, I take any reaction for that matter. Say I'll take the same reaction, H2S plus Cl2 gives HCl plus H2. Okay, I'll take the same reaction here. Right, fine. So your first, we already mentioned the point that oxidizing and reducing agents are going to help you in oxidation and reduction. Okay, now the next question is how? How are they going to help? Right? So basically an oxidizing agent helps in oxidation, reducing agent helps in reduction, but how is the question? Now the question is by sacrifice. Right? How they help us doing something? By sacrifice. What do you mean by sacrificing? Is basically, and for example, if I have an oxidizing agent, right? An oxidizing agent oxidizes something else. Now, how? By reducing itself. That is the sacrifice. That is the sacrifice here. Right? So an oxidizing agent oxidizes something else. Okay, something will undergo oxidation, and it is done by this oxidizing agent. How it is making sure that the other one is undergoing oxidation? By making sure that the oxidizing agent undergoes reduction. Very simple. That is what you mean by the term sacrifice, right? So an oxidizing agent oxidizes something else by itself undergoing reduction. Same way I can tell for reducing agent also, right? So reducing agent reduces something else by oxidizing itself. Right? So what you have to understand is oxidizing agent oxidizes something else by reducing itself. Reducing agent reduces something else by oxidizing itself. Right? So in a question, if they give you a reaction like this, right, and they ask you to find which is the oxidizing and reducing agent, right? It's very simple, people. You already know how to find which is undergoing oxidation, which is undergoing reduction. Right? So can you tell me, guys, in this reaction, what we saw, which is undergoing oxidation? Can you tell me in this reaction? What is undergoing oxidation here? In this reaction, which is or what is undergoing oxidation? Just now we saw, right? What happened, guys?
Sir, can you repeat again, sir? Was breaking.
I'm asking in this question, in this reaction, which is undergoing oxidation, which is undergoing reduction? That's my question. Your voice is breaking, Kana. I'm not able to hear anything. Maybe put in the chat box.
H2 is oxidizing, sir.
See, you have to be very careful, right? So whenever I ask you these kind of questions, I told you that you should not speak about hydrogen in whatever form it is. Okay. Other than that, you see two elements here, that is sulfur and chlorine, right? Only one of them will undergo oxidation, the other one will undergo reduction. Now tell me, sulfur or chlorine, which will undergo oxidation, which will undergo reduction?
Sir, sulfur, sir.
Sulfur will undergo
oxidation.
Okay, correct. Right, very easy. Again, I mentioned, you see, sulfur is along with hydrogen, but in the product side, sulfur is alone. That means from sulfur, I have removed hydrogen. From sulfur, I have removed hydrogen. So sulfur is getting oxidized. And obviously chlorine you have, and to chlorine you have added hydrogen in the product side. So obviously chlorine is the one which is getting reduced. Okay, now how do we find which is the oxidizing and reducing agent? Very simple, people. Whichever, now I told you, an oxidizing agent undergoes reduction and a reducing agent undergoes oxidation, right? So now whichever is undergoing oxidation, that will be the reducing agent in the reaction, and whichever undergoes oxidation will be the reducing agent in the chemical reaction. Very simple. Now in this case, in the question which we are seeing, right? You see sulfur is getting oxidized, or I can call sulfur as the reducing agent. Now, in this case, you see chlorine is undergoing reduction. So I will call chlorine as oxidizing agent. Okay, right? So sulfur is undergoing oxidation. So that is the reducing agent. Now chlorine is undergoing reduction. So that is the oxidizing agent. I hope it's very clear. So once you find which is undergoing oxidation and which is undergoing reduction, right, you can easily find out what is the reducing agent and what is the oxidizing agent. Whichever is undergoing oxidation, that is the reducing agent. Whichever is undergoing reduction, that is the oxidizing agent. Very simple. Ulta pulta. Right? So guys, I think you are not still familiar with, this oxidation reduction reactions. Okay. I mean, which is undergoing oxidation, which is undergoing reduction. I think you are not very familiar with. We'll solve some questions also. Don't worry. Right? Okay. So anyways, for now, this is enough for us. Right? We'll solve more questions, but we understood the concepts, right? What is oxidation? What is reduction? How to find out which is undergoing oxidation, which is undergoing reduction, and lastly, what is oxidizing and reducing agents? Okay, right, fine. Now, this oxidation, especially, actually, like oxidation, especially, we come across this this particular phenomena in our day-to-day life so many times. Okay, now they have mentioned two such things in your NCERT textbooks, right? So first one is what is called as corrosion, right? I think you might have already studied about this, right, in your lower classes, or at least you would have heard people talking about this at least, right? So what do you mean by corrosion? Very simple, right? So generally, what happens is I will have a metal bar, right? Generally, metals will be in solid form. Say this is copper, for example, or iron, or zinc, whatever it is. Some metal is there. Okay. Now, if you keep this metal exposed to the atmosphere, okay, you just keep it in your room, or you keep it in your veranda, somewhere, right? Somewhere wherever it is exposed to the outside atmosphere, basically exposed to air. Okay. So what will happen is these elements, right, will say this is the surface. Assume that this surface is only exposed to the atmosphere. Okay. Right. Now, obviously, the atmosphere will have some gases. Say oxygen will be there, and nitrogen will be there, hydrogen will be there. So many gases will be there. Right. Out of that, this oxygen alone is very reactive. Oxygen is very reactive. Okay. So what is going to happen? This surface, right? This surface is exposed to oxygen will react with oxygen. Right? This surface which is exposed to the air will react with oxygen. And when it reacts with oxygen, obviously some kind of compound will be formed. For example, if Fe reacts with oxygen, I am going to form iron oxide, ferric oxide, Fe2O3. Right? So what will happen is you will see a coating of the metal oxide on the surface of the metal. Okay, so now this is the entire metal. The surface, that is the open surface, is exposed to the atmosphere. So now the oxygen in the atmosphere and the metal surface, which is containing the metal, obviously, right, will undergo some kind of reaction. Right. So when they undergo reaction, what you form is a metal oxide coating. I would say a metal oxide coating on the surface of the metal. Right. So this entire process is what is called as your corrosion. Okay. Now someone asks you, what is corrosion? Just tell them that when I have something exposed to the atmosphere, the metal and the oxygen will react to form a coating of metal oxide on the surface. That phenomena is what is called as your corrosion. Again, I repeat. When you expose it to the atmosphere, oxygen and the metal will react, form a coating on the surface of metal oxide. This entire phenomena is what is called as corrosion. Okay. Yeah. Any questions? Is there any question, Kana? Yeah. No. Okay. Fine. If I hope everything is clear, right? Okay. So what else? Or is there any question? I'm not able to hear clearly what you're saying. Okay, fine. I hope there is no question. Right. Okay. So this formation of metal oxide coating on the metal surface is what is called as corrosion. And obviously it is bad, isn't it? Right? Because I want only these metals to be present. Right? You must have faced this problem when you had magnesium. If you remember this reaction, Mg plus O2 giving MgO. Right? So what happened? Before I move on to this reaction, this magnesium has to be rubbed with sandpaper, if you can remember. Why I had to do it? Because there will be coating of magnesium oxide already on the surface of the magnesium ribbon, right? So to remove that, you go for sandpaper. You remove the coating on the surface, then you make the reaction happen. Right. So obviously, when you have rubbed with some sandpaper, obviously amount of magnesium is lost. Is it not? Some magnesium would have formed magnesium oxide, and that coating only you're removing. Is it not? Say I had 10 grams of magnesium, but say in the coating, I had in that some 2 grams of magnesium would have gone along with magnesium oxide, right? I mean, in the form of magnesium oxide, right? So obviously this 2 grams is a loss to us, correct? So like this, I have, so every element undergoing oxidation, every element undergoing corrosion, that will, lead to depletion of the metal. We go for wastage. Is it not? Lot of elements get wasted due to the phenomenon of corrosion. Okay, right. Now, a specific type of corrosion, right? A specific type of corrosion is what is called as your rusting, right? Now, rusting is basically corrosion only, right? But we speak only for iron. Corrosion of iron is what is called as rusting. Very simple. Okay, so someone asks you what is rusting, tell them that it is nothing but corrosion of iron. And what is corrosion? You are again explaining this. Like the metal surface is exposed to the atmosphere, the metal surface and the oxygen will react to form a metal oxide coating on the surface. That is what is called as corrosion. A specific form of corrosion, that is, if corrosion happens in iron, that corrosion is what is called as roasting. Okay, and a very famous question, guys, they will ask you, what is the reaction of rusting? You have to write the reaction, they'll ask you. Okay, now please understand, it is not only oxygen, right? We generally say that it is metal oxide coating. It is not only oxygen, people. It can be sulfur, it can be sometimes even moisture, basically H2. Okay, so all these stuff can interfere and form the coating. It is not, it need not be only metal oxide coating. It can be sometimes even metal sulfide coating. Okay, right? Fine. Now you must have already seen so many times iron rods. Say iron rods, you must have seen in the welding shops and all. You will always see some, like say this, if this is the metal, right? Maybe if I can take some brown color. Do I have a brown color? Yeah, something like this. You will see that there'll always be a coating, right, on the iron surface, right? This is what is called as your rust. Okay. Now, if you ask me what is the formula of this rust? Very simple. The formula of rust is Fe2O3 dot XH2O. Right? I know I'm going to form metal oxide iron. This is iron alone, and obviously from the atmosphere I'll get the oxygen. So they will, and obviously oxygen plus water molecules, that is moisture. Some X molecule. This I know. This is water crystallization, guys. Right? This dot X2O is my water of crystallization. Right? So this Fe and the oxygen will react to form a coating on the surface of iron that is called rust. Right? And the formula of the rust is nothing but Fe2O3 dot XH2O. Very, very important. Okay. So if I have to write the reaction for this, very simply I can write Fe plus O2 forms, I mean, obviously the presence of moisture H2O will form Fe2O3 dot XH2O. XH2O. This is the equation for rusting. You have to remember this. Lot of times in your board exam, this question will be asked. Okay, now it is oxidation only, right? Iron is undergoing, iron is getting added to oxygen, or oxygen is getting added to iron. So iron is getting oxidized. And if you ask me, sir, what is getting reduced? What will be your answer to this question? In this particular, forget about H2O, forget about this. If I have Fe plus O2 giving Fe2O3, right? I obviously know for sure iron is getting oxidized. What is getting reduced? What is getting reduced here?
Oxygen.
Yes, very simple. Again, the same thing, right? Oxygen will be 0 here, charge, and here it will be -2. So obviously for this, you would have added electron to this. So definitely oxygen is the one who's undergoing reduction, and iron is the one who's undergoing oxidation. As simple as that. Okay. Now there are a lot of other corrosion problems, right? Say for example, in copper, right? Now you must have seen copper vessels which you use in your houses, right? Copper vessels.
Sir, for the
Okay.
last equation, sir, why did we write
Yeah.
dot x H2O, sir?
Okay, because the formula of the rust Fe2O3 alone is not anhydrous, right? It will obviously have some moisture content. Now, what you understand is, right, if I look at the surface, if I look at this particular thing, what I drew here, this is also something like a crystal, is it not? Right, this is also like something like crystal formation on the surface of the metal, correct? So this crystal, when it is getting formed, it is not only FeNO2, right? The moisture from the atmosphere, water vapor, I can say water vapor from the atmosphere also reacts, right? So when it reacts, it is not going to react. It is just going to be in the form of water of crystallization, because it is going to be in the form of crystal. This rust, what you see, I can assume that it is actually in the form of crystal. So that I can understand why do I have a water of crystallization, that is dot H2. Yes, understood, Kana?
Yes, sir, understood.
Okay, good. Right. So now other examples can be this copper vessels, right? If you use copper vessels in your this thing, old copper vessels, right? When you go for old copper vessels, right, they will have a green coating. They will have a green coating on them. Again, say same problem. Problem is corrosion, right? The copper will be exposed to the atmosphere, and this green coating is nothing but copper sulfide. Write it as copper sulfide. So in this case, the gas from the atmosphere which is undergoing the reaction is not oxygen, but in this case it is sulfur. That's the only difference. Okay, in this case it is not oxygen. In this case it is sulfur. But again, this thing is very similar. I have the metal surface exposed to the atmosphere. Gases will react. I form a coating. Right? In this case, it is a green coating. And what is the green coating made up of? The green coating is made up of copper sulfide, right? CuS. Okay, right? Fine. So these are all the various ways. These are all the various examples of corrosion. And how do we come across it? Right? So there will be a lot of wastage, right? You can see, for example, iron we use in your construction materials. So many other things we use iron, right? So like what it says is that our country almost loses 5% of GDP due to corrosion. Right, our country, right, India, right, due to this problem of corrosion, right, and rusting, right, we use 5% of GDP. GDP is nothing but gross domestic product. It's like we're losing a lot of money. That's what you have to understand, right? The entire country suffers because of this corrosion. Okay, right. So how do we come across this? There are ways by which you can come across. Okay, now I don't. Some of the ways I'll tell you. First one is what is painting. Right? Say now you have the iron surface with you, right? The iron rod with you. You paint it with something. So obviously, what is happening when you paint it? When the incoming gases come, say oxygen comes, it will not find iron, but it will find only the paint. Right? So that the iron and the oxygen are not in contact. Only if they are in contact, this reaction will happen. The formation of rust will happen. If they are not in contact at all, then obviously I can go. I don't have to worry about corrosion. So first way to come across, or say to overcome this corrosion, is painting. Paint on it. Right. Second one is what is called as galvanization. Guys, do you have all these things in your syllabus? Did your school teach you all this galvanization and all?
No, sir.
No. Okay, fine. Maybe I'll not go into the details. Just explaining. Right. Painting, we understood how are we going to overcome this. Galvanization is very simple. Okay. Say now I have the metal surface. Okay. Now the problem is this metal surface will meet the oxygen or sulfur, and they will undergo some reaction, form a coating. That's the problem. Right. So galvanization is basically any color I take. Right. So galvanization is basically you coat the surface with some other metal. Say this can be zinc. Say if this is iron, right? The coating you make is zinc. Okay. Now what is going to happen here? The same thing in what happened in case of painting. Zinc is going to make sure that oxygen can only react with zinc and it cannot go to iron. Okay, right? So this is like a sacrificial method. The zinc is going to get sacrificed, right? Zinc will undergo a reaction with oxygen to form ZNO, right? Making sure that it protects the iron, which is of very important value. Okay, very simple. Galvanization is basically meaning adding coating the surface with zinc. That's it. So that it is going to prevent oxidation of the metal by zinc itself undergoing oxidation. Right? Very simple. Galvanization. There are various other methods. We will not go into the details. Okay, right? So two things you have to remember, people. One is the rust, right? And what is the equation of formation of rust? And second thing is about the copper old vessel, right? Why is it having a green coating? All these kind of questions can be asked in your exam. Okay, fine. Now we are talking about oxidation. Now one of the natural phenomena you see regarding oxidation is corrosion, obviously. Okay, now the other natural thing which we see in our daily life is what is called as rancidity. Okay, now very simple. Rancidity means spoilage of food. Right? Now, obviously, right, any kind of food item, right? Any kind of food item, you keep it open to the atmosphere. Obviously, it is going to get spoiled. Right? In Tamil, right? I hope all of you, most of you are from who knows how to speak Tamil, even though your native is not Tamil Nadu. We say "Oosi porudhu." Okay, that's a common term your parents will use. "Oosi paidichu," something like that they'll use. Right? Oosi paidichu means it's spoiled. You will not be able to eat it, or obviously whenever it spoils, obviously you will have very bad smell, right? And obviously you wouldn't have tasted it, but if you taste it, obviously it is going to be bad. Right? I don't like the thought of it itself is is creating some sensations. So all you have to understand is rancidity means the phenomenon of food getting spoiled. Okay, and if it happens, obviously the food will smell bad, it will taste bad, the texture changes, right? Right? Obviously, if at all you have rice, you open the rice and go, and tomorrow morning you will see that it would have become like a semi-solid thing if you have seen it, right? So that's what I'm telling you. The texture changes. Now, why is it happening? Again, same because of oxidation only. Right? So again, you keep the food particles open to the atmosphere, the oxygen will come, react with this, form some compound, and that compound is the reason for all these things. Okay, so if someone asks you define rancidity, you define rancidity as oxidation of food, as simple as that. Okay, what is rancidity? Rancidity is nothing but oxidation of food particles. Very simple, right? Obviously, if it undergoes oxidation, that is what it is called as. It is undergoing spoiling. It is spoiled, bad taste, bad smell, texture changes. Everything will happen, right? So to overcome this, right? To overcome this only, we cover everything, right? Or say, we use sometimes use something called as antioxidants. I think this term also you must have been hearing a lot of time, right? This in your chips packet, like your famous Lay's chips, right? So they will be actually, it will be obviously they go for marketing. Inside that there will be nothing, it will be mostly air and only 2-3 chips will be there. Anyways, so you will see that the cover is buffed up, isn't it? There'll be a lot of gas. When you open it, a lot of gas comes out, right? Now those gases are actually antioxidants. Okay, now this antioxidants prevents oxidation. Right? Just like when we told about corrosion, you go for painting or you go for galvanization, that is a coating of zinc, right? So how do you overcome rancidity is by using something called as antioxidants, which will prevent oxidation of food particles. Okay, right? So that is what is about rancidity. Very simple, right? So these two are the real life phenomena. What are the real time phenomena? Corrosion, and that to rusting, a specific form of corrosion, and rancidity. These are all the real life examples we see for oxidation. Okay, what is the time? Okay, we have 5 more minutes. Maybe we'll see what is given in the text. Oh, there are so many charts which I didn't see. Sorry, guys. Rust is also something like crystal. Yes, correct. Is it necessary in the reduction reaction that O2 will be removed? Yeah, not necessarily. We have seen some reactions, right, where oxygen or hydrogen is not even involved. Okay. Fine. Can oxygen be oxidized? That's a good question. We'll see about it. Right. Fine. Look at this. Oxygen. Can oxygen be oxidized? That's a very nice question. I like this question. Right. Oh, 1 second. There is some background noise. Just give me a moment. Okay. Right. So people, oxygen can actually exist in 3 different ionic forms. Okay, again, see, this is just extra information for you. If you don't want to remember this, don't remember this. Anyways, we'll study again the same thing when you go for 11th class. Okay, fine. So oxygen, I told you, can exist in 3 different ionic states. One is my O2 minus, which we already know. This is my normal oxide ion, right? There is something called as O minus. O minus is peroxide. Okay, oxide is O2 minus. There is something called as peroxide. Now you must have seen when you have gotten hurt, when you fall down and got hurt in your, say, knees and all, someone will put hydrogen peroxide solution on the wound. I don't know whether you know this. Somebody knows hydrogen peroxide solution they will use for cleaning the wounds. Do you know that? Anybody knows? Okay, no issues. Right. So you can go to the medical shop and ask for hydrogen peroxide, H2O2. Right. So this H2O2 is used for disinfectant. Right. It is used to clean the wounds and all. Okay. So anyways, so in this hydrogen peroxide, oxygen will be in the form of O minus. Okay. And there is one more thing. I can even have O to the power minus half. Okay, now this is what is called as your superoxide. For example, I have something called as KO2. Okay, KO2 is potassium superoxide. Okay, now the question, like, can oxygen be oxidized? Now look at this. If I convert O2 minus to O minus, right? If I convert, from example, oxygen to O2 minus, definitely this is reduction. No doubt about it, right? Because you have to add 2 electrons to this. Okay, but if I convert O2 minus to O1 minus, what should I do? Should I remove electron or add electron? Think about this and tell me. From O2 minus, if I have to form O minus, I have to remove electron or add electron?
Remove electron, sir.
Obviously, right? Now there is 2 electron, 2 minus here. There is only 1 minus here. So obviously an electron is coming out. Okay, but this, so what do you say? You remove an electron from something. So this becomes oxidation. So yeah, for the answer to your question, can oxygen be oxidized? Yes, it can be oxidized. Okay, because there are different forms of what to say, the ions of oxygen present, oxide, peroxide, superoxide. Okay, but again, nothing you have to remember. Don't remember any of this, please. Okay, right? So that it was just to answer the question. Okay, fine. So now maybe we have 3 more minutes. Maybe we'll just go through the activity if possible. Somewhere in the chat. Yeah, remove electron. Yeah, correct. Guys, I would prefer for you to, actually unmute yourself and speak. Okay, because sometimes I might not see the chat, right? Okay, so look at this activity, last activity. Heat a China dish containing about 1 gram of copper powder. Right, now very simple, guys. Whenever you're heating and that copper, now you see this is the China dish, right, containing copper, and obviously it is not closed. This is open to the atmosphere. Okay, so now oxygen from the atmosphere will come. So copper and oxygen will react. You can see copper and oxygen will react to form copper oxide. Okay, right now. Okay, now this copper oxide, remember that copper oxide which you form is black in color. Okay, copper oxide you form is black in color. So what do you observe? You observe a black coating. That is what you will observe. Okay, right. So then now you can see this is undergoing oxygen, this is undergoing reduction. Now you see copper oxide, this reaction you see copper oxide reacts with hydrogen to form copper and H2O. Okay, now you see copper oxide was there here. So copper was along with oxygen. Okay, right. Now from copper oxide, you have removed oxygen to form copper. Right. So I will tell this is not the correct way of writing it. You should tell that copper is the one which is undergoing reduction. Why reduction? Because I have removed oxygen from copper. Same way, you see hydrogen was here, right? In the product side, hydrogen is along with oxygen, right? Hydrogen was alone. In the product side, you see hydrogen is along with oxygen, in the sense that to hydrogen, I have added oxygen. So H2 or H is the one which is undergoing oxidation. Right? So like this, you have to practice, people. You have to practice a lot. Okay, you have to practice in a given reaction which is undergoing oxidation, which is undergoing reduction. You have to know in your fingertips. Right? You can see these are redox reactions. Zinc oxide. Okay, now tell me about this reaction. No? Right, zinc ZnO plus C gives a zinc plus CO, which is undergoing oxidation, which is undergoing reduction. Tell me here. This reaction, ZnO reaction, ZnO plus C gives Zn plus CO. I want to know which is undergoing oxidation, which is undergoing reduction. Come on.
So C is undergoes oxidation and Zn undergoes reduction.
Absolutely. Right. So you have to tell that carbon undergoes oxidation because you see carbon is alone here, but in the product side, I have added oxygen to carbon. So definitely carbon undergoes oxidation, and zinc, we should not tell zinc oxide, right? We should tell zinc. From zinc oxide, I have removed oxygen to form zinc. So actually I have removed oxygen. So this is reduction. This is how you should speak. Okay, so guys, like this, you must, understand for all the reactions, what is undergoing oxidation, what is undergoing reduction. So we saw corrosion, right? We saw rancidity, right? And that's it, done. So we have successfully completed all your chapter. I mean, with this first chapter, sorry. Okay, this first chapter is completed. Okay, now look at this question, guys. Oil and fat containing food items are flushed with nitrogen. Why? Any idea? Oil and fat containing food items are flushed with nitrogen. Why? It is something related
so
to
that
what we saw.
oxygen does not get reacted with it.
Okay, so I'm just expecting one term. So nitrogen acts as, nitrogen here is acting as.
So it is an inert gas.
Okay, I told you one term. What is the term?
Sir, antioxidant.
Antioxidant. That's the thing. So here, nitrogen acts as an antioxidant. That's what you have to understand. Right? Oil and fat particles are flushed with nitrogen because nitrogen makes sure that the food particles doesn't get oxidized. Means nitrogen acts as an antioxidant. Right? And you see, why do we apply paint on iron articles? Obviously, to prevent rusting. Okay, right? So like this, a lot of questions can be asked. Right? Okay, guys, I think the chapter is over. So next week, right, we'll be starting with your acid, bases, and salts. Okay, right? Any questions you have? Anything you want to ask me? Any questions, guys? Okay, I suppose there are no questions. If there are any questions, you can always WhatsApp me or you can ask me next class, whatever it is okay for me. So that we have completed successfully first chapter. Okay, I hope you find whatever my teaching is okay for you. I'm not going so fast. I am not complicating things. Okay, if there's any problem, you are welcome to say. Any criticism is welcome. Yes, Sanyu, any doubt?
No, sir.
Okay, fine, guys. Thank you so much. We'll meet again next week. Right, thank you so much. I'm going to end the class.
Thank you, sir.
Thank you, sir.
Thank you.